Hello and welcome to finding the acceleration and tension of coupled bodies. Let me introduce what I've got here. We have a 7 kilogram mass and a 3 kilogram mass. The 7 kilogram mass has a coefficient of friction of 0.1. The 3 kilogram mass is just hanging here, and I've already done the free body diagram, calculated the weight of the second body. The 3 kilograms is mg. 3 times 9.8, 3 kilograms times 9.8 meters per second squared gives me 29 newtons, and that's negative because it's down. And I found the weight of the other object, 7 kilograms, and the normal force. So the easiest thing to do from this point is to start by finding the force of friction. So, if you follow along in the blue, that's where I'm working. The normal force times coefficient of friction will give me the force of friction. That would be 68.6 newtons times 0.1, the coefficient of friction, and that gives me a force of friction of 6.86 newtons. Now the next thing we can look at is the acceleration of the entire system. So that would constitute everything in this pink circle. I'm using pink because this is the color of the second object, which is giving us the force that's going to make it go. Okay, so here's the good old F equals ma. Solving for A with the net force over the total mass. The net force on this object, both of them coupled together, would be the weight minus the force of friction divided by the two masses combined. Substituting in the values, and we find the acceleration of this system. Hmm. 2.254 meters per second squared. Might want to pause and take a look at that and study that and see what those numbers are telling you, what the formulas are showing you. Again, this is the net force divided by the total mass. Now let's look at the tension. How are we going to find the tension? Well, we can use either of these two masses. I'm going to start with this one over here. The acceleration of this object and the tension and the weight, which is causing the acceleration. So following along in the blue box, net force equals the mass times acceleration. The net force is made up of the weight and the tension, the weight being down, the tension being up, times the mass, the second mass of 3 kilograms, times the acceleration, which is down. Now we need to solve for tension. The tension is equal to the second mass times the acceleration that second mass is experiencing. That's the 2.254 minus the weight. Now we're ready to substitute in the values. The force of tension then is equal to 3 kilograms and negative 2.254 because it is accelerating downward. Following the formula, minus Fw, The weight is also negative because it's downward. Solving for the first term, and then minus a negative is plus 29.4 newtons. And we have an answer of a tension of 22.638 newtons. Now, it should not matter if we didn't choose this one. If we chose to work over here with the other mass, it's the same string. It should be the same tension. So, following along with my blue highlight, the net force equals mass times acceleration. This time we're using M1, the 7 kilogram mass. The net force is made up of two forces, the tension from the string and the force of friction in the opposite direction. Now, tension is equal to mass times acceleration of that mass minus the force of friction. Substituting in values, 7 kilograms, choosing to the right as a positive direction. So the acceleration in this equation is positive, minus the force of friction, which is a negative because it's in the opposite direction. Solving for the first term. Then the force of tension, 22.638 newtons. I hope this was helpful. Just reviewing. The force of friction is the coefficient of friction times the normal force. The acceleration of this system, they both share the same acceleration. So it will be the total force, the net force, which is the force of weight minus the force of friction, divided by the total mass, 3 plus 7 kilograms. Looking at the tension, again, the net force on this object, the 3 kilogram mass, is the weight and the force of tension, and that's equal to ma, the mass times the acceleration that this body is experiencing, 2.2 meters per second squared, and the solving for the tension, and then substitute in the values, being extremely careful that you get your signs correct. Define one direction as positive, then the other direction as negative, and make sure that you are consistent. We chose down to be negative and up to be positive, so the acceleration of this body is negative and the weight of this body is negative. The tension therefore is positive because it's up. Looking at the other body, again, the net force times the mass times the acceleration that this mass is experiencing, 2.2 meters per second squared. The net force is made up of the tension and the friction. For this body, I'm going to choose the direction to the right as positive and to the left as negative. Substituting in, again being very careful, using positive for positive direction and negative numbers for the negative direction. 7 kilograms times 2.2 meters per second squared, the acceleration that this body is experiencing, minus the friction. The friction is a negative because friction is in the opposite direction to the left. And then it's just calculator work. If you solve for the tension from both bodies and you don't get the same answer, then you must have done something wrong, because the tension throughout the string is always going to be the same. Thanks very much.